Hello everyone, welcome to the OneClass channel. My name is Marlon. I'm a second year student at the University of Waterloo studying chemical physics with a math minor. Today I'm going to be working through some high school and college level chemistry problems. Be sure to check out the links in the description if you're in need of any extra homework help or would like some one-on-one tutoring. Okay, so for our first question, we're going to be looking for the Lewis formulas of the following. And so we start by counting the valence electrons. We have 2 from beryllium and 2 by 7 from the fluorine, and then we don't have any charges. So that is just going to give us 2 plus 14. So we have 16 electrons to manage. Let's go ahead and label these. This is from beryllium, and this is from the 2 fluorines. Okay, and so we start with a skeleton that looks like that. Let's go ahead and add 1 bond in between them and the necessary valence electrons around the fluorines. Let's count to see if we hit the 16. So 2, 4, 6. We have 6 by 2 plus 2, 4. So 12 plus 4, and that's going to give us 16, which means we have covered all of the electrons. And so this is allowed because in this scenario we have an underfilled octet for beryllium. So let's just go ahead and note that down. Additionally, let's check our formal charges to make sure that it all makes sense. So for the fluorines, we will have F, and that is going to be 7 valence electrons, minus each of them have 6 non-bonding electrons, and only 2 bonding electrons, so 2 over 2. And that is going to give us 7 minus 6 minus 1, which is going to give us a formal charge of 0. On the beryllium, we're going to have 2 minus 0 non-bonding electrons, minus 2, 4, so 4 over 2 bonding electrons, and that's just going to give us 2 minus 2, and that is also 0. So the formal charges check out, valence electrons check out, which means that this is going to be our final structure. Move on to the next one. That is BeF3 minus. Let's go ahead and count the valence electrons. So we have 2 from the beryllium, plus 3 by 7 from the fluorines, plus 1 because of the charge. Let's go ahead and label those. So this is BeF3 minus. And so that's just going to give us 3 plus 21. So we have 24 electrons to manage. So we start with just the skeleton of this, and 1 bond on each. Let's fill in our valence electrons on each of the fluorines, so fill their octets. Okay, and then let's see if we hit the 24. So we have 6 on 3 of the fluorines, plus 2, 4, 6, so 3 by 2. And so that is going to give us 18 plus 6, and that is indeed our 24. So you see all of the electrons have been managed here. And so let's go ahead and check our formal charges. And again, this is going to be allowed because the beryllium will again have an underfilled octet. So now let's go about checking the formal charges. So again, it's the same formula of valence electrons minus the lone pair electrons minus the bonding pair over 2 electrons. And so for each of the fluorines, that will give us 7 minus 2, 4, 6 lone pairs on each of them, minus 2 electrons in a bonding pair for each of them. And that is just going to give us 7 minus 7, which would give us 0. Let's check in on our beryllium. 2 valence electrons, minus it has 0 lone pairs, minus 2, 4, 6 bonding pair electrons. And that is just going to give us 2 minus 3. And that's going to give us -1. In this scenario, that does make sense. We're asked for this, and it has the negative charge here. So the negative charge is being caused by the beryllium. And that is going to be our final answer. The formal charges make sense, and the valence electrons make sense. On to our next one. ER3. Let's go ahead and check on our valence electrons. And so we have 3 plus 3 by 7. And so that's going to give us 3 plus 21 again. And that's going to give us 24 electrons to manage. We can go ahead and just label them. So this is caused by the aluminum. This is caused by the 3 bromines. And so let's start with our skeleton structure. And start with 1 bond on each and filling in the octets of our halogens. Okay, count our valence electrons. We will have 6 by 3 plus 2, 4, 6. 6. That is going to give us 18 plus 6, which again will give us the necessary 24. And so again, this will be allowed because aluminum will have an underfilled octet. Let's go ahead and count our formal charges. Let's just write down the formula very quickly. And so for our aluminum, that is going to be 3 minus 0 minus 6 over 2. And that's just 3 minus 3, which is 0. For our bromines, that is going to be 7 minus 6 on each of them, minus 2 over 2. And that's going to give us 7 minus 7, which is again 0. And that again makes sense because we had a net charge of 0, which is allowed according to the formal charges we have on each of them. And so this is going to be our final structure again. And those are our final answers.